So, Neil, I mean, how big a problem is this? I mean, do you see many people out there?
I see 95% of projects acquiring some technical debt. Why is that? As I say, even the null release, and we define the null release as follows: the time it takes for you as a project to release a new version after one line of code that's changed. So you're changing one line of code, how much time, testing effort do you need to make in order to up-issue and release the new version of your software? You want that to be a minimum. The way you achieve the minimum is high levels of automation. So you want a change-based testing approach where you make a change and the impact of that change is instantly assessed. A tool like VectorCast and managed, obviously, by monitoring the file system, checks to see which tests need to be recompiled and which need to be rerun in the event of any change on the file system, which is exactly what you want. You want thousands of test cases. Software's getting larger, it's getting more and more complex. So you often have tens of thousands of unit test cases, many of them automatically generated. You maybe don't have time to rerun them all, so you want to know that with this change, which parts of my software are affected. So you need a change-based testing approach to keep that technical debt to a minimum.
Okay. So, I mean, what sort of customers have it? Because this sounds like a pretty challenging situation. Is this something that's limited to a smaller business or a bigger business? Or, I mean, what sort of companies do you see having these kind of issues today?
We see customers in all vertical segments with a technical debt issue. Obviously, in the safety space, where formal testing is a larger overhead than perhaps in a less regulated industry. So formal testing obviously takes more time, maybe consumes more of the development lifecycle, estimates of more than 50% for a safety critical project. Technical debt very quickly builds up there, particularly when the code has to be kept in sync with documentation and maybe the architecture in something like Enterprise Architect or the model. So we see technical debt very clearly in those situations in safety critical, but also in pretty much any other software project where there is a set of requirements, changing customer demands, particularly in agile framework where customer says, well, I want this button to be green and not red, even the small changes. We see the buildup of technical debt. It's very easy for technical debt to come into a project, and so it does need to be managed and measured.
Okay. So, Neil, I mean, this all sounds pretty daunting, and it seems like there are a lot of kinds of software businesses and just generally businesses that are trying to enter into software that are having this challenge. I mean, is it really a problem? Is this hype? Is this, the next kind of, year 2000 bug, Y2K bug, or is this really an issue? I mean, are you seeing businesses really finding challenges here and trying to work through it?
We are finding every day in the papers, in the press, stories of software failures, stories of release schedules slipping, software not being released, devices not being ready because of software problems, firmware updates, crash-causing instances. There are so many projects that have been delayed because of software faults. If we trace that down, very often I believe we would find that that's due to a technical debt where the business side has put pressure on the development team to release something perhaps before it's ready, or the estimates in the first place haven't been correctly managed. Expectations haven't been set correctly by the development. It takes a long time to develop good quality software, and if we don't have a culture of building quality in from the building blocks upwards, from the bottom upwards, then we will get technical debt. It's a very big problem. It's a huge problem in the industry. It particularly affects large projects where there is a legacy code base. I visited 2 customers today in London. We're talking applications now. 20 million lines of code is quite common. One person even told me today their code dated back to 1975. The original developers have long gone. There's no documentation. There's a need to understand quickly what this code is doing. There's also a desire to refactor and reuse that code base. Everybody wants to reuse. That makes sense economically and technically, and from a business point of view. Let's reuse code that's already been done. But you need to obviously understand that code. And that's where something like VectorCast, if you are in that situation where you have a legacy code base, not very well documented, perhaps not so many tests that have been run against that, use the baselining to generate the the actual behavior, so to record the actual behavior of the software. Then if you're happy with the behavior of those components, set the actual to the expected behavior, which is easily achievable in the solution. Then you have a baseline to manage changes going forward. And then you can manage deltas, and you have a confidence to go forward, knowing that you've got full coverage, the tests pass, and that you're managing the change. So I think change management is what we need here. Also, it's very noticeable that if you looked on something like LinkedIn, there are now job titles called complexity managers. So software is getting so complex that there are specialists now who are managing that complexity and having to deal with this complexity. So if you have an architecture which is maybe not the intended architecture, not a hierarchical system like this, but maybe you've got some spaghetti code, you've got some clustering, you've got some dependencies that are causing some issues, tests that affect other parts of the software that shouldn't do, then we can analyze that, and then we can start to baseline the behavior and then make positive changes going forward. So yes, I think it's a big problem, but thankfully there are advanced technical solutions out there to address that problem.